Welcome back. This is Module 7 or Chapter 7 in our CompTIA Security Plus textbook. We're going to be talking about identity and access management. This is an important concept in information assurance. From this chapter, you should be able to describe the different types of authentication credentials, list the authentication best practices, and define access controls and explain how they can be used. Okay? So these are the different types of authentication credentials. This again is like something, somewhere you are, something you are, something you have, something you know, something you exhibit, something you can do, and something you know. That's different than someone you know. See, in the someone you know, that's validated by another person. Something you know is knowledge that nobody else possesses. Like, say, like what's your mother's maiden name, or what is your first pet, things like that. Okay, and then you can read the description in the different scenarios. So you're somewhere you are. So if you're on campus, usually like when you're logging into Blackboard or Banner, you don't have to use the security app. Okay? Whereas if you're off campus and you're dialing in or you're connecting in, it'll usually ask you to what's called the two-factor authentication. It'll send you that access code request. So that's an example of some of those. Okay? So something you know, maybe a password. The most common type of identity authentication management authentication today. Passwords provide weak protection and are constantly under attack. So why are they weak? Well, the weakness of the password is linked to human memory. Oftentimes we'll put in, and I hate to say it, I've seen some people that have PASSWORD. Okay. Long complex passwords are most effective, but they're also hard to remember. Users must remember passwords from many different accounts. Each account password should be unique. Don't use the same password for all these other accounts. Why? If they guess one, they'll get into all of your accounts. Many security policies mandate that passwords must expire. So like every, 6 months, every year, or whatever that policy might be. So here's the idea of like creating a password. This username Braden Thomason. Okay. And the password sunshine _1 $. It's changing it to that what's called ciphertext. In this case, it's just encrypted to the JS plus Z $MSRJFI. I'm sorry, F or just R. Okay, so then that's what you can see it stores in the database. Okay, Braden Thomason and then encrypted password. That's why oftentimes when you're on a website in US, I don't know what my password is, they won't tell you what your password is because they don't know it. It's encrypted. It's hashed. In this case, it's like a one-way hash. And so all they can do is, after they authenticate you, is give you a password reset link. Okay. So here's where you would retrieve a password. They type their username and password, the information sent to the server scrambles the password and creates that digest, and then compares that to what's on the database. If they match, then congratulations, you are authenticated. Okay. So it never compares the sunshine $1 . It compares that cipher text. So in what's called a brute force attack, every possible combination of letters, numbers, and characters are combined to attempt to determine the user's password. So like PASS01. PASS02, and PASSWORD01, PASSWORD02, and every combination. A password spraying attack selects one or few common passwords and then enters the same password while trying to log to several different user accounts. The attackers work to steal the file of password digests so that they can then just cross-reference that. And they can load that into a file on their own computer and use a sophisticated password cracker. An offline brute force attack uses a stolen digest file, and what it's doing is it's just like trying to break into a safe. It's just going one after another. In a dictionary attack, it uses words from the dictionary, common words like house, horse, cow, farm, friend, whatever. And credential stuffing occurs when the attacker injects a stolen username and password across multiple websites to try to see which one he might hit. So it might be like Amazon's website, maybe eBay's website, maybe a banking website, maybe say YSU's website, or whatever the case might be. A rule attack constitutes a statistical analysis on those stolen passwords that's used to create a mask to break the largest number of passwords. There are 3 basic steps in a rule attack. A small sample of the stolen password plaintext is obtained. Statistical analysis is performed on the sample to determine the length and character sets of the passwords. A series of masks is generated so that it'll be most successful in cracking the highest percentage of passwords. So here's an example. We have a rule attack and a statistical analysis. So you can see as it's analyzing that. And this is again something you know, the passwords. Here's an advanced mask statistics, or again rule attack generated masks. And you figure, why does somebody want to spend their time doing that? Well, because gaining access to your account might be beneficial to them. The most common items to use for something you have, authentication, are tokens, security keys, and even smart cards. A token is a type of object that can be a hardware or software. One type of hardware token is a window token that displays a dynamic value called a one-time password. A software one-time password is generated through an app on a user's smartphone. You also have multi-factor authentication. It's a type of authentication where a user is using more than one type of authentication credential. It might be that your username and password, plus it's sending you that, like in YSU, you have the additional login information. Example, what a user knows, and then what user could be used together for authentication. So here's the password, and like in Google or Gmail, from Google, it'll get the proof. Is this you? Yes or no? And then you're authenticated. A more secure option is using a dedicated token key known as a security key. One feature security keys is its attestation, which is a key pair that is burned into the security key during manufacturing time and is specific to a device model. A smart card is a credit card sized plastic card that can hold information to be part of that authentication process. A smart card covering all U.S. government employees is called the Personal Identity Verification, or PIV standard. Here's an example of a security key. Again, this is something that you would have, again, in your pocket or so forth. Then something you are your biometrics, your facial recognition, your fingerprint, your retinal scans, and things like that. So if you've ever go look at some of those Google data center videos. There's one in particular where they show you the security. The manager there shows where he has to have his badge has to be on record, and then it does a retinal scan to let him into the inside of the center. So your physiological biometrics for a person include the physical characteristics for authentication. So you have a retinal scanner, like I mentioned that. You have a static fingerprint scanner, a dynamic fingerprint scanner. The static fingerprint scanner is a picture and accompanies with the image on the file. Some of the laptops have those dynamic fingerprint scanner. They're a small slit where you just drag your finger across it. A vein scanning tablet. A person's veins can be identified, a person's gait or the manner of walking. You have your voice recognition. You've seen that on some of the some movies where they want to recognize the person, an individual. They recognize their voice and voice pattern. The iris scanner and the facial recognition using landmarks called nodal points on a human face for authentication. Again, that's like holding up your phone if you set it up to unlock when it's held up to your face. Some biometric disadvantages: the cost of specialized hardware scanning devices. Those things are expensive. Eventually, hopefully, the cost of things like that will come down. Also, the readers have some amount of error. I mean, if your fingerprints are dirty, they won't match than what you've had before. Biometric systems can be tricked. Okay, a final concern with biometrics is the efficacy rate for which the benefit is achieved. Is it really worth all that effort just to get that additional security? Or should you use something else? Cognitive biometrics relates to perception, thought processes, and understanding of the user. It's considered easier for the user to remember because it's based on a user's life experiences. Cognitive biometrics is also called knowledge-based authentication. A picture password was introduced by Microsoft with Windows 10 touch-enabled devices. Users select a picture for which there should be at least 10 points of interest that could serve as landmarks or places to touch. You also have behavioral biometrics, authenticates by normal actions the user performs. The behavior might be keystroke dynamics, the way they type, their typing rhythm. Okay, the dwell time, how long does it take to press and release a key? The time between keystrokes, so it's called the flight time. Your keystroke dynamic hold a great amount of potential because it requires no specialized hardware. Okay, here's our first knowledge check activity. Amali is researching elements that can prove authenticity. Which of the following is based on unique biological characteristics? So we can rule out the word something, because all four of those have something in it. Okay. So is it what you exhibit, what you have, what you are, or something about you? Unique biological characteristics. Think about that. Well, it's going to be something that you are. It's based on unique biological characteristics that cannot be changed. Okay? One method of protecting password digest is called salting. And just like you would add salt to food to add flavor, you're using a random string that's added into that hash algorithm. Passwords can be protected by adding a random string to the user's clear text password before it's hashed. So salt makes dictionary attacks and brute force attacks much slower and limits the impact of what are called rainbow tables. If you ever remember your networking or your security part of that. A rainbow table is where they've already generated a hash, they've already generated plain text and the corresponding hash. So all you have to do is when you come across a hashed value, just look it up on that rainbow table, and you instantly have a password that will unlock it. Another strategy is called peppering, where the message digest is created as normal, but then encrypted with a symmetric encryption key before it's stored. A more secure approach for creating password digests is to use key stretching. Key stretching is a specialized password hash algorithm that's intentionally designed to be slower. Three key stretching algorithms are bcrypt, BBK DF2, and Argon2. Solutions for managing passwords include the following: password vaulting. That's like a security vault. It's a place where you would store all your passwords. User password managers, hardware password keys, and using password best practices. Your password vaulting stores the user password credentials in a highly protected database or vault that is stored on the organization's network. A user password manager is a software application or online website that stores user passwords along with login information. And a hardware password key often serves as a hardware-based password manager. So here's an example of a password key. Okay, you have the only key, and then you put that information in there, and then it transmits through those wires you see at the top. Some password best practices include the following. A default password should be always changed. So whatever they set up, whatever the default password should always be changed to something strong. Password reuse should be prohibited. Don't use last week's password, yesterday's password. Don't use last year's password. Okay, password age should be set to at least 1. So that you should change, in this case, however many days, weeks, months, or whatever. Provisioning should include policies that address password best practices. Deprovisioning should have policies such as suspending accounts when an employee leaves the organization. You don't want them to have access once they've left the organization for whatever reason, whether they retire, whether they've been fired, or whatever. So you also have single sign-on. The identity management is using a single authentication credential to share it across multiple networks. For instance, here at YSU, if you log into Banner, you can automatically log into Blackboard. Or you can automatically log into your email once you've logged into Banner. The Federation, sometimes called Federated Identity Management, or FIM, is when networks are owned by different organizations. The single sign-on, or SSO, uses a one authentication credential to access multiple accounts or applications. Your technologies for SSO include secure assertion markup language and lightweight directory access protocol. Your security assertion markup language is an XML standard that allows secure web domains to exchange user authentication and authorization data. SAML allows user login credentials to be stored with a single identity provider instead of being stored on each web service provider's server. Your lightweight directory access protocol makes it possible for almost any application to obtain directory information. Developers use LDAP to allow SSO if a single login were to grant access to all databases, apps, and devices on that server. So here's an example of SAML transaction. You can see it passes that the user attempts to reach the service provider. And it goes 1 to 2 to 3. Then on the right side 4, and then 5, and then 6 and 7 and 8 back to the service provider. So here's another secure authentication technology, OAuth or Open Authorization, OpenID, and Shibboleth, and that's the open source software package for designing SSO. Those three types of our tools. So you have secure passkeys. They refer to various methods for storing authentication information in hardware. Passkeys do not rely on passwords. They combine multiple authentication factors into a single package that is managed by the device's operating system. Passkeys are also discoverable, which means an enrolled device can automatically push a passkey through an encrypted tunnel to another device that it's attempting to sign into. Okay. Here's our activity check number 2. Which of these is not, repeat not, a key stretching algorithm? Argon 2, bcrypt, PBK, DF2, and MD5. So look at them. That means we need to find, because 3 of the 4 here are correct. We want to find the one that's wrong. So what do you think? Remember, don't look ahead to the next slide because that gives the answer away. You want to be able to learn this on your own so that you're able to say, aha, I know what this is. Okay, so here we go. It's MD5. Using a general purpose hash algorithm like MD5 and SHA is not considered secure for creating digests because these hashing algorithms are designed to create a digest as quickly as possible. The fast speed of general purpose hash algorithms works in an attacker's favor. Okay, so if you go back, remember it listed those 3 that were the safest ones. Or rather, a key stretching algorithm. Okay. So we're in an access control scheme. It's a predefined framework embedded in the software and the hardware that administrators can use for controlling access. The discretionary access control scheme is the least restrictive, where every object has an owner who has total control over that object. There are 2 weaknesses of DAC that include the following. DAC relies on decisions by the user to set security. Well, did you ever hear the phrase, a chain is only strong as its weakest link? Well, it looks like the user is the weakest link here. Permission will be inherited by any program the subject executes. Okay, so those are the 2 weaknesses. Here's an example of Windows discretionary access control. You can see that here where it's setting, some people have full control. The system has full control to modify, read, others, administrators, or even in this case Mark Campana, may have just read, execute, and modify, and not full control. And you can see that when you work in Windows access control. You can have mandatory access control. Now that's different than the media access control, which is your MAC address. The mandatory access control assigns users access control strictly according to the custodian's desires. So the following are 2 key elements in the MAC. One are labels, where every entity is assigned a classification label, like students, faculty, and so on. And then levels in a hierarchical based on the labels for use for objects and subjects. Microsoft Windows uses the mandatory access control that ensures data integrity by controlling access using the Security Identifier, or SID. You have your role-based access control. It's based on the user's job, function within an organization. Okay. Your rule-based access control is used for managing users' access to one or more systems where business changes may change the access rule. You have your attribute-based access control, using more flexible policies that can combine attributes. Okay, so here they are listed in this table here. Mandatory access control, discretionary access control, role-based access control, rule-based access control, and attribute-based access control. This is nice to have this little, if you're ever working with these, it's nice to have this table to have this explained like that. So you have what's called access control lists. Some of you that's ever worked with router and things like that, you understand a little bit more about what an access control list is. It's a set of permissions or authorizations that attach to a particular object. The list specifies who are allowed to access that object and what operations they can perform on it. Access control lists also provide file system permissions for protecting files managed by the operating system. Some disadvantages of access control lists include the inefficiency and difficulty to manage in an enterprise setting. Enterprise meaning that lots of traffic that you're having to deal with the stuff on the fly like that. Okay, which access control scheme uses flexible policies that can combine attributes? So does it ABAC, RBAC, MAC, or DAC? You might ask yourself, did we actually cover that, or what does that word mean? Remember, these questions sometimes are just extras to throw you off. You want to say, if I don't know or I'm not sure about that, say, nope, I don't think that is. You want an access control scheme that uses flexible policies. Okay, so flexible policies is going to be your ABAC. While the rule-based control scheme uses predefined rules, the attribute-based control uses more flexible policies that can combine attributes. These policies can take advantage of many different types of attributes, such as object, subject, and environmental attributes. This is an important point when you're dealing with access control schemes. Okay? Okay, so we're reaching the end of the chapter here. Rate your competence in the following module objectives on a scale of 1 to 5, where 5 indicates that you have full confidence in your competence of that object, and 1 indicates that you have very little confidence in your competence of that objective. If you self-score less than 4, you should consider reviewing that module and the related exercises. Remember, you want to be able to pass that CompTIA Security Plus exam, and you want to be able to do well on that. So you want to describe the different types of authentication credentials, list authentication best practices, and define access controls and explain how they can be used. Okay? And I believe this is the end of the chapter. Okay. That's it for this lecture. We'll see you in the next lecture. Have a nice day, everybody.